Okay. I hope I'm audible now. So any one of you can tell me last class where we have stopped, because I'm not able to remember exactly where we stopped. You ಹೇಳಿದ್ರೆ ಸ್ವಲ್ಪ help ಆಗುತ್ತೆ. So we have covered this convex mirror and concave mirror, image formation and the uses. Yes, sign conventions. We have discussed sign conventions. You both also don't remember or what? Where we have stopped last class? Yes, Shreya, Panchmi.
Some sign conventions of students.
Till there we have discussed. No, okay. I hope this diagram also we have discussed. That is regarding the mirror sign convention. So from here only I'll start. That is sign conventions we were discussing. What is sign convention here? Here for the numerical simplification, we require, that is whether we need to consider the terms as positive or negative. That is nothing but the sign convention here. So for the sign convention, here the concave mirror we are taking that, and we have 5 points here. So what are the 5 points for the sign conventions? That is, here all the measurements are done from the pole. All the measurements are done from the pole. You can see in the picture P is written here. So PL ನಿಮಗೆ ಕಾಣ್ತಾ ಇದೆ, that is the pole point. Okay. So this is our pole here, and from pole we do the measurement. From pole we do the measurement. Whether you are measuring left side or whether you are measuring right side. So you just need to remember that we need to do the measurement from the pole. Here we will consider, that is, this is x-axis, this is y-axis. So whatever time, velocity, distance, whatever I want to measure here, from where we will measure in the graphs, we will measure it from the origin. Howda? The origin points are 0, 0. The original coordinates are 0, 0 here. From the origin, we do the measurement. ಅದೇ ತರ ಇಲ್ಲಿ ಮಿರರ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ, we do the measurements from the pole ಅಂತ ಹೇಳ್ತೀವಿ. Okay, so this is first point. The measurements are done from the pole. The second point is, here you can see the right side and the left side. If you are measuring from the pole, if you are doing the measurement to the right side, then it is taken as what? Positive. The right side measurements are taken as positive, and the left side measurements are taken as negative. Okay, means for example, here AB is your object, but where it is placed to the left of the mirror it is placed. Howda? So left of the mirror al object iddaga object distance anna ನಾವು minus alli tagontivi. Yes, the right side measurement, for example, this is your mirror, here is the object. The distance between the mirror and the object is called as object distance. The object distance is measured in terms of negative. Yes, so this is second sign conventions. That is, the right side measurements are taken as negative. Sorry, right side measurements are positive and the left side measurements are negative. Next, third point is the principal axis. You know that this is the principal axis, xy, x dash is the principal axis in the figure. So principal axis ಮೇಲ್ಗಡೆ measurements ಅನ್ನ positive ಆಗಿ ತಗೊಂತೀವಿ. Below the principal axis, the measurements are taken as negative. So in short, ನಿಮ್ಗೆ ಹೇಳ್ಬೇಕಂತ ಅಂದ್ರೆ, ನೀವು ಈ ತರ ಏನಾದ್ರೂ xy coordinates ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, this is x dash, this is y dash. Okay, so x dash, y dash is there. Here, whatever the measurements we are doing, the measurements on the right side, okay, ಈ ಕಡೆ ಇದ್ದದನ್ನ positive ಅಂತ ತಗೊಂತೀವಿ. The left side measurements are taken as negative. The above measurements are taken as positive and the below measurements are taken as negative. Okay, yes, so this is regarding the sign conventions. So this will help us to calculate the numericals in the next upcoming slides. I hope the sign convention is clear to you. Here we have the formula which is connecting between the radius, focal length, image distance, and the object distance. Here, what is object distance? The distance between the object and the mirror. So, object matte mirror gain distance irutte, that is called as the object distance u. What is image distance? The distance between the image matte mirror gain distance irutte, that is called as the mirror distance. Image distance, that is denoted by V letter. Okay, then the focal length is taken as F. Here we have the relation between all the three terms. ಏನಂತ ಬರುತ್ತೆ? It is 1 by F is equal to 1 by V plus 1 by U. That is the reciprocal of the focal length is equal to the sum of the reciprocal of the image and the object distances. Howda? So here we have one more relation, that is the relation between the focal length and the radius of curvature. It is R divided by 2. F is equal to R by 2, or else we can also write it as R is equal to 2F. R is equal to 2F. So this is the relation between radius of curvature and the focal length. Okay. Yes. So this formula is known as what? Mirror formula anta heltivi. The formula is known as mirror formula. Okay. So we will solve the questions based on this. Okay, here it is written, that is object distance is U, image distance is V, F be the focal length, R be the radius of curvature. Here we have one more definition, that is called as the linear magnification. So linear magnification ಅಂತಂದ್ರೇನು? ಎಷ್ಟು ದೊಡ್ಡದಾಗಿ ನಿಮ್ದು image produce ಆಗುತ್ತೆ, that is called as what? Magnification ಅಂತ ಹೇಳ್ತಾರೆ. Okay, so here how much magnified image you are getting by using the mirrors or the lenses, that is called as the magnification. Here we have two formula to calculate this magnification of the given object. The magnification is denoted by the letter M. This magnification is equal to height of the image to the height of the object. Height of the image to the height of the object is called as what? Magnification. Yes. The one more formula for this magnification is, it is minus V divided by U. What is V here? V is the image distance. What is U here? U is the object distance. Yes. So the ratio of the height of the image to the height of the object is called as magnification. Also, the ratio of the distance of the image to the distance of the object is also called as magnification. So ಇಲ್ಲಿ ನೋಡಿ, ಎರಡು ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಅಂತ ಹೇಳಿದಾಗ ನಾನು ಇದನ್ನ ಇಕ್ವೇಟ್ ಮಾಡಬಹುದಾಗಿದೆ. ದಟ್ ಇಸ್ ಹೈಟ್ ಆಫ್ ದ ಇಮೇಜ್ ಟು ದ ಹೈಟ್ ಆಫ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು minus V divided by U, because both are magnification is equal to. So from this equation you can calculate HI, or you can calculate HO, you can calculate V also, you can calculate U also. So ನಿಮ್ಗೆ ಏನು unknown terms ಬರುತ್ತೆ, ನೀವು ಅದನ್ನ ಇಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದಾಗಿದೆ. Yes. So any doubt is there in the sign convention, mirror formula and the magnification? I hope you are understanding. I'll go for the next concept. Yes. So refraction of light. What do you mean by refraction of light? So refraction, already now we discuss reflection phenomena we have discussed already. Yes. So what is reflection? Reflection is nothing but what? The bouncing back of light in the same medium is called as reflection of light. So reflection allenagatte, you will have a surface. On this surface, when the light ray will incident on this surface, it will return back in the same direction. So this phenomena is called as what? Reflection of light, and this is called as the normal, angle of incidence, angle of reflection. So same way, what is refraction here? Refraction is nothing but what? when the light ray will incident on the surface, it will change the direction of propagation. ಇಲ್ಲಿ ನೋಡಿ, the light ray ಇದೇನಾಗ್ತಾ ಇದೆ, ಇದು ಈ ಸರ್ಫೇಸ್ ಮೇಲೆ ಬಂದು ಹಿಟ್ ಆದಾಗ it should travel in the same direction, ಹೌದಾ? But it is not doing that. What this light is doing, the light is changing its path. The light is changing its path. Here the light is incidenting. So after this incidence, the light will change its path of propagation. So now light in travel ಮಾಡುತ್ತೆ, we use the word propagation. So what is propagation here? The light will move. So instead of using the word move, we use the word propagation here. So what is propagation here? When the ray of light is incidenting on the surface, it will change the direction of propagation. Is called as what? Refraction of light. So here we can show the normal drawn. Yes. So this is the angle of incidence. This is the angle of refraction anta ಹೇಳ್ತಾರೆ. So here we have the angle of incidence and the angle of refraction. What is angle of incidence? Angle of incidence is nothing but what? That is the angle between the incident ray and the normal ray. ಏನಂತ ಹೇಳ್ತೀವಿ? Angle of incidence ಅಂತ ಹೇಳ್ತೀವಿ. What is angle of refraction? Angle of refraction is defined as, it is the angle between incident ray and the reflected, and it is the reflected ray. Okay. So next we have the denser medium and the lighter medium. 1 minute. Okay, so here the angle of incidence and the angle of refraction we have studied. What is the refraction of light? That is, when a ray of light is traveling from one medium to other medium, it will change the direction of propagation. Is called as refraction of light. ಹೌದಾ? So ನಾನು ಈಗ ಏನಂತ ಹೇಳಿದೆ ನಿಮ್ಗೆ, it will change the direction of propagation ಅಂತ ಹೇಳಿದೆ. So change the direction of propagation ಅಂತ ಅಂದ್ರೆ, that is, here this is the surface, this is my incident ray. When this ray of light is traveling to the other medium, for example, ಇದನ್ನ air ಅಂತ consider ಮಾಡಿ, ಇದನ್ನ water medium ಅಂತ consider ಮಾಡಿದ್ರೆ. So when it is traveling, this different medium ಇದೆ, yes. So when it is traveling from air medium to water medium, it will change the direction. Means, suppose if I take this as a normal, when it is moving from air to water, it will bend towards the normal. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? So here refraction means what? The light will change the direction of propagation. So when it is changing the direction of propagation, when it is moving from air to water, it will bend towards the normal. Towards the normal ಅಂದ್ರೆ normally closely refract ಆಗುತ್ತೆ. Suppose if it is traveling from water to air medium. So So water to air medium iddaga, this is my incident ray. So when it is traveling from water to air medium, it will bend away from the normal. Yes. So the light will show this phenomena when it is traveling from one medium to the other medium. It will change the direction of propagation. So when it is moving from air to water, it is bending towards the normal, and when it is moving from water to air, it will bend away from the normal. So why this is happening? What is the reason for this bending of light? So light ಇಲ್ಲಿ ಯಾಕೆ direction change ಮಾಡ್ತಾ ಇದೆ? Yes. So here 2-3 reasons we can give. First, I'll tell you why it is bending towards the normal and away from the normal. See, compared to air and water, which is rarer medium ಮತ್ತೆ which is denser medium ಅಂತ ನಾವಿಲ್ಲಿ ನೋಡೋಣ. So rarer medium ಅಂತ ಅಂದ್ರೆ ನೀವಿಲ್ಲಿ for time being you think that whose density is less, it is rarer medium, whose density is more, it is denser medium. So Shreya and Panchmi, in air and water, which is rarer medium, which is denser medium? So rarer medium means the density will be less, denser medium means the density will be more. Yes. See, here whatever you are seeing the two medium, that is the air and the water medium. For air medium, the density will be less. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? So air is a rarer medium and water is a denser medium. Water is a denser medium. So if you are not understanding this, I'll explain you the laws of reflection. Then I'll tell you what is this rarer medium and what is this denser medium. Okay. Yes. So here, the laws of refraction, it is defined as, I'll consider the surface. This is my incident ray and this is the normal drawn, and here is my refracted ray. So incident ray, the refracted ray and the normal drawn. This is called as angle of incidence and this is called as angle of refraction. Okay. So here in trigonometry, we will study the identities like sine, cosine, then tan, then cot, then sec, and one more is cosec. So ee tara navilli 6 identities anna maths alli study ಮಾಡ್ತೀವಿ. These are the trigonometric terms here. In this, we will consider the first one, that is sine. I hope you have studying this in your 10th class. That is the sine of angle of incidence to the sine of angle of refraction. The sine of angle of incidence to the sine of angle of refraction. This is constant anta ಹೇಳ್ತೀವಿ. So whatever this constant you are taking, sine of angle of incidence to the sine of angle of refraction, ನಾವಿಲ್ಲಿ ಏನು constant ಅಂತ ಹೇಳ್ತಾ ಇದೀವಿ, this is taken as n. So ಕೆಲವೊಂದು book ಅಲ್ಲಿ n ಅಂತ ಕೊಡ್ತಾರೆ, ಕೆಲವೊಂದು book ಅಲ್ಲಿ mu ಅಂತ ಕೊಡ್ತಾರೆ. So whatever this n and mu are there, these are constant, and this constant is called as refractive index anta ನಾವು ಕರಿತೀವಿ. This constant is called as refractive index. So what is refractive index? The ratio of sine of angle of incidence to the sine of angle of refraction is called as refractive index. Yes. Now the denser medium and rarer medium, we can define it based on the refractive index. ನಿಮ್ದು ಏನಾದ್ರು refractive index value ಜಾಸ್ತಿ ಇತ್ತಂತಂದ್ರೆ then it is called as what? Denser medium ಅಥವಾ heavy medium, heavier medium. If the refractive index value is less, then the medium is said to be rarer medium or lighter medium. Is it clear? What is refraction of light? What is denser medium? What is rarer medium? Then the first law of refraction. So the first law of refraction defines sine of angle of incidence to the sine of angle of refraction. It is constant, and this constant is called as refractive index. Okay. The second law is at the point of incidence. So this is my point of incidence. At the point of incidence, the incident ray, the refracted ray, and the normal drawn all lie on the same plane. Yes. So what are the two laws here? The first law is sine of angle of incidence to the sine of angle of refraction is constant. This constant is called as the refractive index. Then here we have the second law at the point of incidence only. So if I consider this is my xy plane and this is my incident ray, this is the reflected ray, this is the normal drawn. So at the point of incidence, the incident ray, the refracted ray and the normal drawn all lie on the same plane, all lie on the same plane. Yes, Panchami and Shreya, any doubt is there?
No.
Okay. I hope the refraction phenomena is clear to you. So we will see one activity, then we will see some question answers. That is refraction through a glass slab or the refractive index. So refraction through a glass slab or the refractive index. Here we have the activity and the experiment. So in some of the school, they will perform this activity also. Okay, so here you can observe the figure and you can understand what it is. Yes, what is this activity? Here, actually, we need to take a plain paper. So on that plain paper, we are keeping one glass slab. So glass slab ಅಂತಂದ್ರೆ you can consider thick glass material ಇರುತ್ತೆ. So square type ಅಲ್ಲಿ, ಆಯ್ತಾ? So we will be having a glass slab ಅಂತ ಹೇಳ್ತಾರೆ. It is like you can consider like ice cream piece. ಆ ತರ glass ಇರುತ್ತೆ ಅಂತ ನೀವು assume ಮಾಡ್ಕೋಬಹುದು. So we have a glass slab. We are placing it on a plain paper. ಸೊ ನಮ್ಮ ಹತ್ರ ಒಂದು ಪ್ಲೇನ್ ಪೇಪರ್ ಇರುತ್ತೆ, ಅದ್ರ ಮೇಲೆ ನಾವಿಲ್ಲಿ ಸೆಂಟರ್ ಅಲ್ಲಿ ಗ್ಲಾಸ್ ಸ್ಲ್ಯಾಬ್ ಅನ್ನ ಇಡ್ತೀವಿ. ಓಕೆ, now what we will do here, after placing the glass slab, here we will place 2 pins. So some different position ಅಲ್ಲಿ ಎರಡು ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನ ಇಲ್ಲಿ ನಾವು ಪ್ಲೇಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಆಬ್ಜೆಕ್ಟ್ ಇಲ್ಲಿ ಏನಿರುತ್ತೆ ಅಂತಂದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇನ್ ಸ್ಕೂಲ್ಸ್ ನೀವು ನೋಡ್ಬೋದು, ನೋಟಿಸ್ ಬೋರ್ಡ್ ಮೇಲೆ ಅಲ್ಲಿ ಪಿನ್ಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಟು ಸ್ಟಿಕ್ ಎನಿ ಪೇಪರ್ ಆರ್ ಎನಿಥಿಂಗ್, ವಾಟ್ ಎವರ್ ಪಿನ್ಸ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್. ಇಲ್ಲ ಅಂತಂದ್ರೆ ಯಾವ್ದಾದ್ರು ಪೇಪರ್ ಇಲ್ಲಿ ನಾವ್ ಇಲ್ಲಿ ಸ್ಟೆಪ್ಲರ್ ಬದಲಾಗಿ ಇಲ್ಲಿ ಪಿನ್ಸ್ ಅನ್ನ ಹಾಕ್ತೀವಿ ನೋಡಿ, ಆ ಪಿನ್ಸ್ ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಐ ಹೋಪ್ ಯು ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ವಿಚ್ ಟೈಪ್ ಆಫ್ ಪಿನ್ಸ್ ಐ ಆಮ್ ಸೇಯಿಂಗ್. ಸೊ ವಿ ಆರ್ ಪ್ಲೇಸಿಂಗ್ ಹಿಯರ್ 2 ಪಿನ್ಸ್. ಓಕೆ, ಈ ಪಿನ್ಸ್ ಏನಾಗುತ್ತೆ, ಆಬ್ಜೆಕ್ಟ್ ತರ ಆಕ್ಟ್ ಮಾಡುತ್ತೆ. ಸೊ ದೀಸ್ 2 ಪಿನ್ಸ್ ಆರ್ ಆಕ್ಟಿಂಗ್ ಲೈಕ್ ಎ ಆಬ್ಜೆಕ್ಟ್ ಹಿಯರ್. ಸೊ ಅಟ್ ಒನ್ ಎಂಡ್ ಯು ಆರ್ ಪ್ಲೇಸಿಂಗ್ ದಿಸ್ 2 ಪಿನ್ಸ್. ದೆನ್ ನೆಕ್ಸ್ಟ್ ವಾಟ್ ಯು ವಿಲ್ ಡೂ, ಯು ವಿಲ್ ಕಮ್ ಟು ದಿಸ್ ಸೈಡ್. ಸೊ ಫಸ್ಟ್ ನೀವು ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀರಾ, ಇಲ್ಲಿ ಸ್ಲ್ಯಾಬ್ ಇಡ್ತೀರಾ, ಗ್ಲಾಸ್ ಸ್ಲ್ಯಾಬ್ ಅನ್ನ ಇಲ್ಲಿ ಎರಡು ಪಿನ್ ಅನ್ನ ಫಿಕ್ಸ್ ಮಾಡ್ತೀರಾ, ಕಡೆಗೆ ಏನ್ ಮಾಡ್ತೀರಾ, ಯು ವಿಲ್ ಕಮ್ ಅಟ್ ದಿಸ್ ಪಾಯಿಂಟ್. ಸೊ ಯು ವಿಲ್ ಕಮ್ ಅಂಡ್ ಸ್ಟ್ಯಾಂಡ್ ಹಿಯರ್. ಸೊ ಆಫ್ಟರ್ ಕಮಿಂಗ್ ಅಂಡ್ ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಹಿಯರ್, ವಾಟ್ ಯು ವಿಲ್ ಡೂ, ಯು ವಿಲ್ ಸಿ ಫ್ರಮ್ ಹಿಯರ್ ದ ಗ್ಲಾಸ್ ಸ್ಲ್ಯಾಬ್ ವೇರ್ ದ ಇಮೇಜಸ್ ಆರ್ ಫಾರ್ಮ್ ಹಿಯರ್. ಓಕೆ, ಸೊ ನಿಮ್ದು ಇಲ್ಲಿ ಏನ್ ಪಿನ್ಸ್ ಇತ್ತಲ್ಲ, ಆ ಪಿನ್ಸ್ ಇಮೇಜ್ ಈ ಕಡೆ ಗ್ಲಾಸ್ ಸ್ಲ್ಯಾಬ್ ಎಂಡ್ ಅಲ್ಲಿ ಕಾಣಿಸ್ತಾ ಇರುತ್ತೆ. ಸೊ ವೆರೆವರ್ ದಟ್ ಪಿನ್ ಪೊಸಿಷನ್ ಇಸ್ ವಿಸಿಬಲ್, ಆಕ್ಚುಲಿ ಎಕ್ಸ್ಪ್ಲೇನಿಂಗ್ ದಿಸ್ ಆಕ್ಟಿವಿಟಿ ವಿತ್ practical knowledge it will be very easy, but I hope you will understand this. ನಾವ್ ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕಂತಂದ್ರೆ, ಒಂದು ಪ್ಲೇನ್ ಪೇಪರ್ ತಗೊಂತೀವಿ, ಸೆಂಟರ್ ಅಲ್ಲಿ ಗ್ಲಾಸ್ ಸ್ಲ್ಯಾಬ್ ಅನ್ನ ಇಟ್ಟಿ ಒಂದ್ ಕಡೆ ನಾವು 2 ಪಿನ್ಸ್ ಅನ್ನ ಅಟ್ಯಾಚ್ ಮಾಡ್ತೀವಿ, Then we will come to the other side of the that glass slab, and ಇಲ್ಲಿ ನಾವೇನ್ ಮಾಡ್ತೀವಿ ಎಲ್ಲದ್ರದ್ದು ಇಮೇಜ್ ಕಾಣ್ತಾ ಇರುತ್ತೆ. So if you come at this end and see, ಇದು ಎರಡು ಏನ್ ಪಿನ್ ಇರುತ್ತೆ, the image of these two pins are visible here. Okay, so after these marks we will just take out the pins and we will just take out the glass slab. ನಾವೀಗ ಏನ್ ಮಾಡ್ತೀವಿ, wherever these first two pins are there, ಎಲ್ಲ ಆಬ್ಜೆಕ್ಟ್ ಅಂತ ಇತ್ತಲ್ಲ, ಸೊ ಅಲ್ಲಿ ನಾವು ಒಂದು ಲೈನ್ ಅನ್ನ ಡ್ರಾ ಮಾಡ್ಕೊಂತೀವಿ. Yes, then next here down also, here we have the 2 points, so we will join those two lines also. Now after removing this slab, center ಅಲ್ಲಿ ನಾವೇನ್ ನೋಡ್ತೀವಿ, that center line also we are joining here. And for our reference we will draw the normal to the surfaces, normal to the surfaces. Yes, so this is the activity. I hope the activity is clear to both of you. Yes, Rehan, every time you are coming late only. Why? Your school is late or how it is? I think physics second class you are attending, but last week also you came late. It's sharp 5 or 5, so till 5:10 we can start, but at least till 5:10 you have to come. Okay, so Shreya, I hope even you have understood what is this activity. So now you can see this. Here it is there. That is refraction through a glass slab. The shortest path need not be a thickest part. Since light is always in a hurry, it bends when it enters a different medium. As it is still following the quickest path, this phenomenon of light bending is called as what? Refraction. So already namu refraction phenomena gottide. Ee refraction antandre enu? The light will change the direction of propagation. That phenomena is called as refraction of light. Yes, here you can see this picture, same picture we have here. Then next here we have some definition like lateral displacement. But the first for the second law ನಾನು ನಿಮ್ಗೆ already ಹೇಳಿದ್ದೆ, that is for the refraction. What is the first and the second law? So what is lateral displacement? See here, the perpendicular distance between the emergent ray and the incident ray produced forward is called as what? Lateral displacement. So ಅಂತಂದ್ರೆ here so if I say this is my glass slab and this is my incident ray, and here it is the emergent ray anta ಹೇಳ್ತೀವಿ. So first ray ಏನಿರುತ್ತೆ, incident ray ಆಗುತ್ತೆ. When it will travel from air to glass, so here it will change the direction of propagation, that is towards the normal it will change. Now it is moving from glass to air, therefore it will bend away from the normal. If I extend this emergent ray, so ನೀವು ಇಲ್ಲಿ figure ಅಲ್ಲಿ ನೋಡಬಹುದು, if I extend the emergent ray in the backward direction, so and the incident ray in the forward direction, this perpendicular distance is called as what? That is lateral dispersion. Lateral displacement, it is called as lateral displacement. Here if I extend this ray in the backward direction, emergent ray and the incident ray, this perpendicular distance is called as what? Lateral displacement. Okay, the first law and the second law already we have discussed. So let us go for the next point. Okay, that is the refractive index. So what is refractive index? Already you know the refractive index is nothing but what? It is the ratio of sine of angle of incidence to the sine of angle of refraction. The ratio of sine of angle of incidence to the sine of angle of refraction is called as refractive index. Here, if you are considering the two medium, antande, this is first medium and this is the second medium, that is air and the water or air and the glass. The refractive index 2 with respect to 1, you can write it like this also, or you can write it like this also. So ಈ ತರ ಬರೆದ್ರಿ ಅಂತಂದ್ರೆ ಇದು ಏನಂತೀರಾ ಸಬ್ಸ್ಕ್ರಿಪ್ಟ್ ಅಲ್ಲಿ ಇದೆ ಆಯ್ತಾ. So it is in the subscript. So n21, what is the meaning here? The refractive index of medium 2 with respect to medium 1. It is given by sine I divided by sine R. Medium 2 with respect to medium 1. Similarly, with respect to 1, the refractive index of medium 1 with respect to 2 is given by, it is V2 divided by V1. And when I say it is N2 by N21, it is written as V1 by V2. So idenantandre namge already en gottide one formula gottide, that is sine of angle of incidence to the sine of angle of refraction is constant. This constant is called as refractive index. Refractive index can also be defined the ratio of speed of light in the vacuum to the speed of light in the medium. So this is the speed of light in the vacuum. Either value constant is it is 3 into 10 raised to 8. It is 3 into 10 raised to 8. Then next, V is the speed of the light in the medium. The speed of light in the medium. Okay. So C value and to change agala, but V value will change from medium to medium. V value will change from medium to medium. Yes. So this is the second definition and the formula for the refractive index. One more is there. The refractive index is also given by V1 by V2. So what is V1 by V2? When it is traveling from first medium to the second medium, this is called as what? Refractive index. Yeah. So three formulas are there for the refractive index. Here you may get a question. What is the unit of refractive index? Yaradru helboda unit en barutte anta. So what does it mean by unit? Force and a Newton mass is expressed in terms of kg, then length is meter. Like, what is the unit of this refractive index? Yes, students, formula is in front of you. Can you tell? Yes. See, velocity or speed unit in meter per second. Yes. So if you substitute in the numerator meter per second, so here it is meter per second divided by here also it is meter per second. So this meter per second will cancel. Therefore, it is a unitless quantity anta heltare. Andre idakke yadu unit illa. Refractive index is just a number. It is just a number. Okay. So if you see for air, the number, the refractive index is 1. So air est baratte, the refractive index value is 1. Then the refractive index, this is for air. Similarly, the refractive index for glass, it is 1.5. This is for glass. The refractive index for water, it is 1.33. This is for water. Getting? So I told you what is refraction. Then next we discussed what is refractive index, laws of refractive index, lateral displacement. Then here we have the values of the refractive index. It will vary from material to material. Adralli air nodidaga 1 anta ide. So what is the meaning here? 1 anta andre very less value here. Therefore air is a rarer medium. And glass is having 1.5, so it is a denser medium. 1.33, it is less than glass but more than air medium. Is it clear? Rehan, Shruti, Shreya and Panchmi. Or if you want me to repeat any concept, I can repeat. You can tell in the chat box or you can. Yes, all three. Okay. So some questions we will see. Otherwise, you feel very bored because we have more theory in this lesson. So you can take your book and pen and you can solve some questions. Okay, then the next class we can see with the lenses. So I'll show you some of the questions. Yeah, I hope you are able to see. Otherwise, I'll just show it in the PPT. Just one. Please see this question. Yes, the question is a concave mirror of focal length 20 centimeter is placed 50 centimeter from a wall. How far from the wall an object be placed to form its real image on the wall? Yes. So see, ಏನೇನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ ಇಲ್ಲಿ, that is they are giving you the focal length of a concave mirror. The focal length of a concave mirror is 20 centimeter. Then it is placed 50 centimeter from a wall. ಅಂತಂದ್ರೆ object distance is given. It is 50 centimeter. Next, how far from the wall an object be placed to form its real image on the screen? So how far the object is placed and the object distance we will calculate ಮಾಡಬೇಕಿದೆ. The image distance is given as 50 centimeter. Okay, we need to use the mirror formula and we need to simplify. See, I told you already the sign conventions. If it is a concave mirror, the left side measurements are taken as what? Negative. So focal length ಅಂದಾಗ ಏನಾಗುತ್ತೆ, pole ಇಂದ ಈ ಕಡೆ ನಾವು measure ಮಾಡ್ತೀವಿ. Therefore, the focal length will be minus for the concave mirror. Similarly, here the image distance is also minus. Why? ಯಾಕಂದ್ರೆ ಅವ್ರು ಇಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, ನಿಮ್ದು ಇಮೇಜ್ ಆಲ್ರೆಡಿ ರಿಯಲ್ ಇದೆ ಅಂತ ಸ್ಪೆಸಿಫೈ ಮಾಡಿದ್ದಾರೆ ಇಲ್ಲಿ. Therefore, the image distance is also minus and the object distance, that is the focal length, is also minus. So what you do, you use 1 by f is equal to 1 by v plus 1 by u formula and calculate the focal length. So will you try and tell the answer? That is v value, you just u value you calculate. So you can substitute here. It is 1 divided by minus 20 is equal to 1 divided by minus 50 plus 1 by u. So if I transfer this, it will be 1 minus 20 minus into minus plus 1 by 50 is equal to 1 by u. You can take the LCM and you can simplify. Otherwise, however you feel comfortable, your wish. Yes, I hope you are simplifying. So here the LCM will be 100. So it is 1 by u is equal to, the students, so you have a contour mirror, 3 centimeter from a wall. From the wall to the 50 centimeter. Yes, you calculate and tell me what you are getting, that u value. This, if you simplify, you will get the value as 33.3. Check. I hope you are simplifying that. You will get it as 33.3. That way you will get minus answer. Okay. So minus 33.3 you will get. But in question ಅಲ್ಲಿ ಏನಂತ ಹೇಳಿದಾರೆ ನೋಡಿ, that is what is given in the question. A concave mirror is placed from 20 that is 50 centimeter from the wall. So suppose this is a wall. This is placed at the 50 centimeter where the object should be placed so that you can get the real image ಅಂತ ಕೇಳಿದ್ದಾರೆ ಅವರಿಗೆ. ಹೌದಾ? So here this distance is 50. But what about this distance? So what we need to do here, again, whatever answer you are getting, that we need to subtract it from our 50. That we need to subtract it from 50. Then you will get the correct answer here. Okay. That is 50 minus your object distance is 33.3. That is minus 33.3. So if you simplify this, you will get it as 63 point something you will get. Understanding? 16.7 you will get. Yes, Panchmi and Rehan. Understood why we have subtracted again, because the distance is not given from the object or from the image, it is given from the wall. So wall in the distance ಕೊಟ್ಟಿದ್ದಾರೆ, ಅದಕ್ಕೋಸ್ಕರ ನಾವು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ನಮಗೆ ಏನು ಆನ್ಸರ್ ಬರುತ್ತೆ again we need to subtract it from the 50 whatever the wall distance is there for the mirror. Is it clear? Panchmi? If you want me to repeat, I'll repeat, no problem. So in the next class, we will continue. Panchmi, did you understand?
I'm not able to hear.
Repeat what you said. Repeat, Panchmi, I did not hear you. You are not able to hear me. Okay, it's okay. In the next class, we will continue. Okay, both of you.